All right, Unit 6, Day 3 of talking about vectors. We're going to do vectors for 2 days, today and tomorrow. And again, there's not a review day built in. There's not a review worksheet built in. It's only 4 days of stuff, and it's really only 2 topics, and it's all calculator. So all of that put together, you don't need a review day or a review worksheet, but just know that ahead of time. So let's see, today's Tuesday, that'll be day 1 of vectors. Tomorrow's Wednesday, that'll be day 2 of vectors. Thursday we'll take the test. So just so you know what's coming. All right, first the definition of a vector. It is a quantity with magnitude and direction. Oh, what movie is that in? Despicable Me. There it is. Thank you. So, yeah, we should probably watch the whole movie just to get to that one line about vectors having magnitude and direction. We don't usually ask for definitions in math class, at least not at this level anyway. When you get way up there, they'll start asking more. But this one we will ask. This one is on the test on Thursday. What is the definition of a vector? So I'm telling you now, make sure you know, a vector is a quantity with magnitude and direction. A quantity with magnitude and direction. A scalar is a quantity with only magnitude. So when we get to, we had that a little bit with matrices. I don't know that I used the word scalar, but if there's a number out front of a matrix, that's a scalar. You're just going to multiply to everything. Same thing works with vectors. If it's a scalar, kind of just multiplies to everything. Multiplying vectors is tricky. We're not really going to do it until tomorrow, I think. Yeah, we'll do that tomorrow, multiplying them. All right, we're going to do 3 things with them today. First thing we're going to do is add them graphically. If you've been in, how many of you have had physics? Either in physics or had physics? Some? Okay. Do you remember the little saying about how to add vectors? With the... You add them tip to tail. So let's say this is vector A, and that's vector B. And we're going to do some things with them. Remembering that vectors are magnitude and direction, you can think of them as if you're following directions that someone gives you, like to get from your house to their house, or to get from the school to their house. You know, you go, what would that be, east on Kingwood Drive until you reach a certain spot, and then you take a left and go north. So thinking of it like that, I think, will help when it comes to adding them. Because if we want to do A plus B, that means we want to travel A, and then we want to travel B. So I need to sort of relocate A over here. It needs to be the same magnitude and the same direction. Now, in physics, when you do this, you get out rulers and compasses and protractors to make sure everything is lined up just perfectly. Here, it's a little more conceptual. I didn't measure that with the ruler. I didn't measure the angle. I can tell by looking, though, that that's the same stuff. So I traveled A. Once I travel A, then I'm going to travel B. So from the end of A, then I'm going to go B. The trick that some people fall into is they do A, and then back here at the beginning of it, they do B. Like, well, that's not how you follow directions. If you're telling someone how to get to your house after they travel down Kingwood Drive, you say take a left. Well, they don't go back to Kingwood High School and take a left or go B. From the end of the first direction, then they go the second direction. So again, think of them as following directions. Travel A, and then you travel B. Now, that's not the answer yet. That's sort of like me saying, I need you to add 2 and 4, and you say, okay, 2 plus 4. Like, well, yeah, sort of, but that's not the final answer yet. The final answer that we're looking for is from where you started to where you ended. This is A plus B. Sometimes called the resultant vector. I don't know why they don't just call it the result. It's the resultant. After you travel A and then travel B, sort of your overall distance from where you started is A plus B. Let's try 2A minus B. So this means I'm going to go A twice, and then backwards B once. So there's A. That might be a little long, but you get the idea. There's A again. So there's my 2A. Minus B, well, we don't really subtract B. We kind of just add a negative B. So a negative B would be going in the other direction. So negative B would be going straight up. So 2A minus B. And then we'll connect where we started to where we ended. Start, end. And that is our resultant. And it's important to put the arrow on the correct end, from where you started to where you finished. You don't draw the arrow back to the beginning. This is not making a circle. You followed these directions and you ended up from here to here. You don't have to highlight your answer. Some people do to kind of make it stand out. It's sort of the equivalent of boxing. Add 2 and 4. 2 plus 4 equals 6, and then you box 6 to let me know. But you don't have to box it. You don't have to highlight it. Let's try, I want you to try with a different B and A. Actually, let's call them something else so we don't get confused here. Let's say that is C. And that's D. And I want you to try to draw C plus 2D. So travel 1C, and then from the end of that, travel 2 Ds. And then don't forget to connect them correctly. C, and then from the end of C, I'll travel D, and I'll travel D twice. And you don't have to label the start and the finish, but if it helps you put the arrow in the right place, start from C, go to the end. So that's C plus 2D. Get it? All right, so that's adding graphically, adding the pictures. Now let's add numerically. All right, vector u. There's maybe new symbols here for you. Vector u is negative 2, 5, and vector v is 1, 2. Those are not ordered pairs, right? Those don't have the parentheses around them like ordered pairs. Those are directions. It's still x, y, but it's directions in the x, directions in the y. So if I wanted to graph vector u, I would go 2 to the left and 5 up. So if that's the starting of u, let's see, 2 to the left, 5 up. So vector u would look something like that. So again, it's not an ordered pair. You don't put a point on a graph. Those are directions. From the start of u to the end of u, 2 left, 5 up. From the start of v to the end of v would be 1 right and 2 up. So there's vector v. So that's what the numbers mean. They represent x and y, but not the point x and y, more like directions in x, directions in y. Right, if we want to do 3u plus 2v, adding numerically is easy. This is good news. 3 times negative 2, 5 plus 2 times 1, 2. So take a guess. What do you think we do with the 3? Distribute it. So I can distribute that 3 and get negative 6, 15. And I can distribute the 2 and get 2, 4. And it's a little bit like adding matrices, where all you have to do is add the corresponding positions. So negative 6 plus 2 would be negative 4. And 15 plus 4 would be 19. So 3u plus 2v would be negative 4, 19. That means if you traveled 3 u's and then 2 v's, you would end up backwards or left 4 and up 19 from where you started. So that's sort of the link between the picture and the numerical. So adding numerical is super easy. You just do what you think you should do. Distribute and add the corresponding pieces. Add the x's, add the y's. And again, you'll have a calculator. So you can't really put in vectors in the calculator, but you can use the calculator to add the numbers if you need them. Roman numeral 3 and final. Length, norm, magnitude. Well, the good news is that's all the same thing. How long is the vector? What's the magnitude of the vector? What's the norm of the vector? That's probably a new word. But they all mean the same thing. How long is the vector? Length, norm, or magnitude. First, let's look at the symbol, how you know that that's what we're asking. It looks like 2 absolute value bars. It's not what it is, but 2 2 bars on either side. That means find the length of U. Peek back and see. We drew U just a minute ago as we went backwards 2 and up 5. So that was -2 and that was 5. And this was a right angle. So how do you think we could figure out how long this piece is? It's not 3. Because they're not like in a line. If you walk backwards 2 and then forwards 5, that'd be 3. But this is at a right angle. Pythagorean theorem. So it's a squared plus b squared equals c squared. So yes, there are Pythagorean triples. 2, 5 is not one of them. 3, 4, 5 is maybe what you're thinking about for a Pythagorean triple. Let's reset who U and V are. Probably use the different letters. We've changed them now. Maybe that would help if I labeled that. But yeah, it's just Pythagorean theorem. A squared plus b squared equals c squared. There's also another way to write a vector. So this is kind of the ordered pair format. There's nothing wrong with that, but sometimes books and worksheets will write it with I's and J's. And I just means in the x direction, and J just means in the y direction. So that's the same thing. -3, 3, -2 is the same thing as 3i minus 2j. Just different ways to write it. Which means, how could I write V in ij notation? What was that again? I heard plus 5j. Yeah, I didn't hear the negative. -I plus 5j. Those mean the same thing. Alright, the last problem we're going to do is kind of put everything together. Let's find the length of U minus 2V. Now that means I need to find U minus 2V first and then take the length, right? Just like parentheses. Do the inside first and then we'll worry about taking the length. So U minus 2V, I'm going to do this one in ij format. 3i minus 2j minus 2 times -I plus 5j. Again, it doesn't matter if you wanted to work the problem as ordered pairs, you can. If you do ordered pairs, you got to just keep track of who's first and who's second. If you do I and j, you can think of it in terms of like terms. So we'll collect the i's and collect the j's. Let's distribute that -2 though. So plus 2i minus 10j. So I collect my i's. 3i plus 2i is 5i. Collect my j's. -2 minus 10 is -12j. But I am not done with this problem yet. I mean, that's U minus 2V. What else do I need to do? So I found this. Yeah, I need to find the length of it. So I now need to find the length of 5i minus 12j. Some people kind of get stuck and they'll draw the picture to remind them that it's the Pythagorean theorem. Others will just say, oh yeah, it's a squared plus b squared equals c squared. Let's see, if you want to draw the picture, you'd go 5 to the right, 12 down, and so your vector would be that vector. And then that would remind you, oh yeah, a squared plus b squared equals c squared. And this one is one of those Pythagorean triples. Do you remember what the triple is? 5, 12. If you don't remember, that's fine. You'll have a calculator. Let's see. 25 plus 144 is 169, and the square root of 169 is 13. Oh, sure, you were thinking 13. It's easy to say now, right? But yeah, 5, 12, 13. So sometimes they show up, sometimes they don't. It never matters because you got a calculator. And so it's not that big a deal if you remember it or not. Fine either way. When they show up, it makes your life easier for sure. All right, so this is Unit 6, Worksheet 3 is today's assignment. So it's a little bit of everything that we just did. So you got